factoring by patterns. Now, for those of you that haven't actually paid attention to factoring, and factoring means just going to separate something into two things that are separated by multiplication. And the first pattern we're going to look at is the difference of two squares. What I want you to be very notice here, this is a difference, that means subtraction, and when I factor it, I end up with something with subtraction and then addition. So, now, I have an example, okay? I want you to notice my pattern. My pattern says I have something squared minus something squared, and I put a circle in a box because I'm going to fill in those circles and boxes, and then I have this example, okay? This example, for 4x squared, I have 2x is what's being squared, so this is 2x, and in the back side, it's 9 is really 3, so this is 3y squared, and then I'll just have to fill in the pattern, which would be 2x minus 3y and 2x plus 3y. So my final answer is the way it would be written, like this, and these are conjugates. That's conjugal pair. It's a special name for them. And that's what you get. If you multiplied it, you would get the difference of two squares. Now, the sum of two squares. Again, it looks an awful lot like the difference of two squares, but what we have is a plus sign here, but I still get a minus and a plus there. I still get a conjugal pair. So, what we're going to do is I'm going to look at my 25x squared, and that's really 5x squared plus 6y squared. All right, so I'm going to put those in my circles in my boxes. This is 5x and 6y. So that's really what I'm factoring. And I'm going to put them in over here, 5x, 6y, I. Okay, and then I have 5x plus 6y, I. Because in this case, I get complex numbers. So my final answer is 5x minus 6iy. Notice I put them in alphabetical order. And 5x plus 6iy. And that's my final factored form. One last pattern we're going to talk about is the perfect square pattern, okay, which means I have something squared in the front, something squared in the back, and 2 times those items squared. So, I have an example. This is really 5x squared, and this is 6y squared, very similar to our difference or sum of two squares. But what I need to notice is right here, this piece here is divisible by 2. And so if I divided it by 2, I'd have 2 times 30, and that should be xy, guys. I have 2 times 30, and 30 happens to be 5 times 6. And I made a mistake when I wrote the problem down because it should have a y, should be an xy there. So now I have my pieces. I know what's in the circle, 5x. I know what's in the box, 6y. I know that 2 times 30, which is really 5 and 6, so I have 5x here and 6y there. So I just have to fill this in. And you're asking me, well, what is this really strange plus minus symbol? Well, if that's a plus symbol there, it's going to be a plus symbol here. If it's a minus symbol over here, it's going to be a minus symbol over here. So this particular problem that I did as an example had the negative sign in front of the 60. So my final factored form is 5x minus 6y, the quantity squared. And that's factoring by patterns. Yeah, if you have any questions, write them down, bring them to class, and we will discuss them. Hope you have a good evening, and goodbye.